Hello students. Now we know that the earth crust has many types of materials in it. There are ores, there is liquid, there is gaseous, there is many substances which is present inside our ore. And from those substances we have different elements, we have different compounds, we have different mixtures. And we have different types of metals, non-metals and metalloids. So in this chapter, we are going to study in detail about metals, non-metals and metalloids. And the name of the chapter is Metallurgy. So the substances which can be found from the earth crust can be pure substances or impure substances. Pure substances can be elements or compounds. Elements can be metals, non-metals, metalloids and noble gases. Compounds, we can know that when two elements combine, then the compounds can be formed. Mixtures are the homogeneous or heterogeneous. So we are going to study about metals, non-metals and metalloids. Now let us revise few basics about the physical properties of metals. Now we know that metals are solid except mercury. Now all these properties you have already learned in your 8th standard if you remember. Now metals are also hard except for lithium, potassium and sodium. Metals have the metallic luster which we call it as shine. If you see iron, you can see shine is there. Copper, we can see shine is there. They are shiny, so they have luster. Metals are also malleable. We can make them into flat sheets. We get iron sheets, we get sheets of different types of metals, so they have the property of malleability. Metals can also be drawn into thin wires, so they have the property of ductility as well. Metals also have high melting and high boiling points. Now there are two metals like gallium and caesium which have the low melting points. Now metals are also very good conductors of heat and electricity, and this is the reason why metals are used in our kitchens. You have utensils which are made up of metals. We have iron tawa, we have different utensils which are made up of different types of metals, and they are also good conductor of electricity. We know that they can transfer the electricity, they can transfer electrons, they can transfer charge, so that is why they are used to transfer electricity from one place to the other place. Now there are two metals, that is the lead and mercury, which are poor conductor of heat. And if you talk about the conductor of electricity, the best conductor of electricity is silver and copper. Also, we know that metals, when they bang together, if you bang two metals, then they will produce a sound, that is, they have the property of sonority. Let us now talk about the physical properties of non-metals. Now, we know that non-metals are not only solid, but they can be liquid also, and they can be present in the form of gases also. So non-metals can exist in all the three forms, that is solid, liquid and gases. If we talk about solids, so there is carbon dioxide, then that is sulfur is there, phosphorus is there, we have carbon, so all these are solid. If we talk about liquid, we have bromine. If we talk about gases, oxygen, nitrogen. So all these non-metals are there. Then non-metals are soft also, except for diamond. Diamond is the hardest natural substance which is present, and all the other metals are not as hard as diamond. Now, non-metals, they do not have shine. We know that if you take coal, it does not have any shine. If you take carbon, it does not have shine. If you take sulfur, it does not have shine. So non-metals do not have shine, so they do not have luster except for iodine crystals. If you will take iodine crystals, so you can see there is shiny iodine crystals. So that means only iodine crystals have luster. Other non-metals do not have luster. Then non-metals are not malleable. If you will try to make them into flat sheets, then they will break, they will not form a flat sheet. Also, you cannot draw them into thin wires, you cannot get wires of non-metals, so that is why these non-metals are not ductile also. Non-metals, they can be having low melting points and low boiling points. Only solid and liquids have low melting and low boiling points. Non-metals are also bad conductors of heat and electricity. So we know this is the reason why the utensils like the tawa, it is having a plastic handle or a wooden handle, so that it does not carry the electricity or the heat to it. Even if you see the plastic covering is there on the wires, so that is because it is a non-metal and it will not conduct heat. That from that we can know that it is a bad conductor of heat and electricity. So except for graphite, all the other non-metals are bad conductor of electricity. Also, non-metals are non-sonorous. They do not produce any type of sound. So after the physical properties, let us now learn about the chemical properties of metals. Now metals are also called as electropositive elements. Now why they are called as electropositive elements? Now electropositive means they have a positive charge. So what metals do is they lose their electron and becomes positively charged ions. We all know if any atom will lose its electron, so it will become a positive charged ion. So that is why what metal does is metal loses its electrons very easily and becomes positive, and that is why they are called as electropositive elements. Now let us understand the chemical properties of metals with an experiment. So now here what we have to take, we have to take a pair of tongs and we have to take a few samples like aluminium, copper, iron, any sample you can take, and you need to burn that sample in presence of fire. So we'll need also a burner. So what we are doing is we are taking a tong, or you can take a knife, whatever you want, and on that you have to keep that sample. You can even take a spatula and you need to burn that sample. So what is happening is that the sample which we have taken, it is heated, and it is also heated in the presence of oxygen. We know that oxygen is present in the air. So when we take copper and when copper is heated, so what happens is it combines with oxygen and it forms what? Copper oxide. So we have taken copper. When you heat copper, it combines with oxygen and copper oxide is formed. Then another metal we have taken, that is aluminium. So when we have taken aluminium, again you need to burn it, and when you will burn it, you will find that aluminium also combines with oxygen and aluminium oxide is formed. So from this what you can conclude, that whenever you burn metal, when the metal comes in contact with oxygen, it combines with oxygen and it forms oxides of it. So from this we can conclude that metals combine with oxygen on heating in the air and metal oxides are formed. So from the last experiment, we could find out that when metals react with oxygen, so they form what? They form metal oxides. So now first property that we are going to learn is about the reaction of metal with oxygen. So when metals react with oxygen, they form metal oxide. So here if we take sodium, when sodium combines with oxygen, it forms what? Sodium oxide. Now one thing about sodium is that sodium is highly reactive, and that is why it catches fire very easily when it combines with oxygen. So that is why what we do is we keep sodium in the kerosene so that any other accidents can be prevented. So first, that when it combines with oxygen, they form the metal oxides, that is sodium oxide. Now when this sodium oxide, when this comes in contact with water, okay, so when any oxides, they come in contact with water, so as they are soluble in water, so that is why what they form is they react with it and they form a base or an alkali. So that is why sodium oxide when reacts with water, it forms a base, that is NaOH, which is an alkali. Okay. If we take another example of magnesium, so here we have taken magnesium, and when you heat the magnesium, it combines with oxygen, and what it forms? It forms magnesium oxide, which is the metal oxide. So now this metal oxide, when it comes with water, so we are taking magnesium. Now magnesium is a metal. So when magnesium oxide reacts with water, it is soluble in water, and it forms what? It forms an base, that is an alkali, which is magnesium hydroxide. So from this we can conclude what? That whenever any metal, when it combines with oxygen, when it is heated, it forms what? It forms metal oxide. And when metal oxide is treated with water, it gets soluble in water and it forms an alkali, or it forms a base. Now in the earlier experiment where we took different metals and we burned them, now what type of flame is produced? So when we burn magnesium, so a bright flame is produced. When we burn iron, then also the brighty flame is produced. But when you burn copper, so it does not burn, but it actually forms a black coating of copper oxide. We know that any metal, when you burn it, it forms copper oxide. But there are two metals like silver and gold which do not react with oxygen, and you cannot find the oxides formed in silver and gold. Even when you burn it at high temperature, no oxides are formed in two metals, that is silver and gold. Now, second chemical property is reaction of metal with water. What happens when metal comes in contact with water? So for this, we are doing an experiment. For this, we have taken a burner, we have taken a test tube, we are taking different samples of metal. We are taking a rubber cork, we are taking a bent tube, and here we have taken a test tube which will invert it, and here we have taken a bucket full of water. So as you start to heat this burner, and here we have taken the soaked glass wool which is soaked in water, and so that whenever you heat it, so water will be released from this glass wool, and the metal which is there, it comes in contact with water. So as you start to heat this glass wool, the metal which is there, it comes in contact with water, and a gas is released. Now that gas is called as the hydrogen gas. Now this hydrogen gas then passes through this test tube, and then you can see that the bubbles come here. That means the hydrogen gas has started to come out. So from this we can conclude that whenever metals react with water, so what is produced is the hydrogen gas. So first we have taken sodium here. So when sodium reacts with water, so first is the sodium hydroxide is formed, that is NaOH, and hydrogen gas is given out, plus some amount of heat is also given out. Then we have taken potassium, and potassium comes in contact with water, so KOH is formed, that is potassium hydroxide, and H2 gas is released, that is the hydrogen gas. So hydrogen gas is formed whenever any metal comes in contact with water. Now when calcium is treated with water, so now as we saw that sodium and potassium, when it was treated with water, when they come in contact with water, so they react very fast and the hydrogen gas is released. But when calcium is treated with water, when it comes in contact with water, so it do not react as fast as the sodium and potassium. It reacts very slowly and less vigorously, but hydrogen gas is released. So here in this we can see that when calcium comes in contact with water, so we get calcium hydroxide and we get hydrogen gas. Now if you treat other metals like aluminium, iron and zinc with water, so one thing you have to remember, that these three metals, that is aluminium, zinc and iron, when you treat them with cold water, nothing happens. When you treat them with hot water, nothing happens. So these three metals, when they come in contact with hot water or cold water, they do not react, but they will react with steam. So whenever steam comes in contact with these metals, they will form their oxides, and also the hydrogen gas is released. So here when aluminium is treated with water, so we get here hydrogen gas. When iron is treated with water, now this water is the gas, that is the steam. So that is why here G is written. So when this comes in contact with steam, steam is also a form of, it is gas, but it is having few droplets of water. So we get hydrogen gas, and when zinc comes in contact with the steam, then also we get hydrogen gas. So they will form their oxides and they will form the hydrogen gas. So from all this we can conclude that whenever any type of metal, they come in contact with water, so the hydrogen gas is released. It can be cold water, it can be hot water, or it can even be steam. So now we know that whenever metal comes in contact with water, they will produce hydrogen gas. But there are few metals like lead, copper, silver, and gold which do not react with water. And so that is why they are used for making coins and other ornaments and jewelries.